So I know you've all been waiting desperately for this devlog video. Welcome back, nerds. Today we'll be talking about an interesting way that I implemented the game loop for Nomads. History time! The model view controller is a software design pattern that has been around for a long time. According to Wikipedia, it's actually its 50th birthday as of 2020. Happy birthday! The model view controller is typically used to create user interfaces. The basic idea is that the model stores data, the controller modifies the data, and the view displays the data. In the context of a user interface, we have a user pressing some buttons. The controller takes those button presses and translates them into methods that update the model. Next, the view interprets the model and displays the data in a human-readable language onto a screen. The user then sees the visuals, uses his brain, and makes some elementary calculations and continues the cycle. The model view controller pattern actually works pretty well for game development. So first we have model. We have tons of data we need to store. Things like player position, object velocity, hit points, tile data, energy levels, stupidity levels, hunger levels, you get it. Next, we have the view. Games are nothing if you can't see stuff happening. In future videos, we may talk about efficient rendering. For now, performance isn't an issue yet. Lastly, we want the player to be able to influence the game through the controller. The controller takes key presses, such as WASD, and translates them into commands to move the character. Mouse clicks should be able to open menus, make decisions, or close the game. However, the model view controller pattern still falls a little short from what we want. Player input should not be the only thing that influences the game state. We want game entities to move by themselves, separate from the player's inputs. Buffalo should be able to run away from players, regardless of whether or not they are being chased. Flowers should be able to grow, regardless of whether or not the player is AFK. Thus, we modified the MVC pattern. Instead of model, view, and controller, I present you data, logic, visuals, and input. Not only are the names more understandable, we've also introduced a game clock. Data functions exactly like the model, nothing more to say. Visuals functions exactly like the view, nothing more to say. The input functions similar to the controller. There are differences. The input should only change the variables in the data that describe how the data should be updated. Now, the logic. The logic runs in an infinite loop, updating the data based on variables changed by the input. So now the model view controller diagram looks something like this. Pretty cool, eh? For short, we have dubbed this pattern bundle logic. The reason I called it bundle logic is because I made a bundle class that puts them all together, functioning like a service locator. Let's see a theoretical example, which is kind of an oxymoron, but bear with me. A simplified example, putting bundle logic into action. Suppose we want to implement the basic WASD movement. How do we do this? Using bundle logic. Now in data, we would store the dude's coordinates, direction, and speed. The visuals displays him at the current coordinates. The input, this is important, changes the direction of the dude. Note that we don't change the position. We just change the direction. Finally, every frame, the logic updates the dude's position. The new position is calculated by adding the direction, scaled by speed, to the original coordinates. Voila! Magic. Demonstration time! We're going to implement the simple WASD controls on this chubby pink boy by following the instructions above exactly. Hint: you start by adding the packages game data, visuals, input, and logic. I'll spare you the implementation details since I already described them in depth earlier. Okay, so now let's run and see what happens. Nice, it works. He seems swell. He can run away. With bundle logic, it is extremely simple to configure the controls, or even alter what the controls do. For example, we can easily swap out the sprite of the pink boy with another, just by changing the visuals and nothing else. We say that the system is decoupled, which means that it is easy to change the behavior of the program in one place without having to change code in other places. The model view controller is already a very powerful model of design. Today, we've modified it to create Bundle Logica, the final boss evolution of human-to-computer interaction. More or less, this is the engine fundamentally propelling every single game title out there. I highly recommend you check out some articles on the topic of game loops, written by people smarter than me, which I have included in the description. So long, nerds!